Hello and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to have an introduction to acids and bases. Basically, this section is very important. It comes a lot in the exams, especially for grade 12, elite, and grade 11 as well. Also, it's very important for the MSAT and the SAT. So let's get started. Introduction to acids and bases. We're going to have a look at the main characters of the acids and bases. For example, if we start with the acids, the taste, as you know, is sour taste. They react with some metals, some active metals, to give off hydrogen gas. We will check the equation. And they conduct electricity in solution. Bases, they have a bitter taste. They feel slippery, and they dissolve fats and oils. Here we have this, we call it the pH scale that we're going to study later on. As you can see in the pH, we have the 7 on the scale, and we call this a neutral solution. When it's higher than 7, it's going to be basic solution, and when it's lower than 7, it's going to be acidic solution. So what are some characteristics of acids and bases? Both of them, they change the color of acid-base indicator. So if you have an indicator, acids will change the color, and also the base will change the color. Also, both of them, they react with each other, and they always form salt and water. So whenever we have acid and a base, always the result or the products are salt and water. All right. Let's talk about the acids. Acids, they have pH always lower than 7. They have sour taste. They produce hydrogen ions. It's very important. They turn the blue litmus paper red. So if you have a blue litmus paper, the acids make it red. They react with active metals to form hydrogen gas. For the bases, as you can see here, you will find that the pH is always greater than 7. They have bitter taste. They produce OH ion, which is the hydroxide ion. Hydroxide ion. Also, they do the opposite of what the acids do. So they turn the red litmus paper into blue. Of course, they feel slippery, and they are sometimes called alkalines. So these are the most important characteristics of acids and bases. Now, we have some definitions of the acid and bases. For example, the first definition, or the first scientist, chemist, he was Arinos. And Arinos said, acid, everything that increases the concentration of the hydrogen ion in the solution. So anything that gives off H positive is going to be an acid. Similarly, for the base, it's everything that increases the concentration of OH negative in the solution. It's going to be a base. So that was Arinos' definition of acid and bases. Bronsted, acid and bases, they said that the acid donates proton. And when we talk about the proton, it's going to be the H ion, H positive ion, the hydrogen ion. We call it the proton when we study the acid and bases. So the acid, they donate, they give away proton, and the base, they accept this proton. And in this section, we're going to focus on Bronsted or Bronsted acids and bases. The third definition of the acid and bases is the Lewis acid and bases. And Lewis said that acid is an electron pair acceptor. It accepts electron pair. And the base is electron pair donor. We're going to focus on this in late sections, but for today, as I told you, and for our section, we're going to focus only on the Bronsted-Lowry acid and bases. What is Bronsted-Lowry acid and base? From its definition, acid, it donates proton. Base, it accepts this proton. So let's check this chemical reaction. For example, I always like to write red for the base and blue for the acid. Now, let's check. NH3 before the arrow, and we have it NH4 positive after the arrow. So let's take these two species and see what happened before and after. Basically, it was NH3. After the reaction with water, it became NH4 positive. That means NH3 accepted one proton. It took one proton. That's why now it's NH4, and the sign of the proton is positive. It takes it from H positive. So this one, according to Bronsted acid and bases, this one is going to be a base because it accepted this proton. Now, what happened to the to H2O? If you check H2O, it was H2O before the arrow. We have two hydrogens, one oxygen and no charge, and then it became OH negative. That means it lost H positive, which means it donated H positive. And according to Bronsted-Lowry acid and bases, the acid donates the proton. So water in this case is going to be the acid here. Now, NH3 accepted one proton, it's a base, and water donated this proton, is going to be the acid. What do we call now those species? Always base, after the arrow, we call it the conjugate base. Conjugate acid. So, any base, it will give you conjugate acid. So here we call NH4 is a conjugate acid. And as well as the acid, after the reaction, it will give you conjugate base. So here in this case, H2O, it was an acid. It gave you OH, so the OH here is the conjugate base. These are the two species in the acid and base reaction. Again, Bronsted-Lowry, the acid give away or donate a proton, and the base will accept this proton. A base will produce conjugate acid, and the acid will produce conjugate base. Now, a new thing about the acid and base, we're talking about the water here. As you can see, water, two molecules of water, this is the first H2O. It will react with another H2O, and we call it the acid-base property of water, because when they react, one of the molecule will lose or will donate the H positive to the other molecule, and this one, it will become H3O positive after accepting the hydrogen ion, and the other one will remain OH negative after donating the OH ion, the hydroxide. Now here, this water accepted So it's going to be base. And this water, this molecule, has donated the H positive, so it's going to be the acid. And that's why we call water, it has double property. It has the acid property or the base property. It depends on where you put it with. For example, in this example here, we put it with a base, so the water in this case, it reacts as acid. Look at this diagram here. This is the two water molecules. And then what happened is this hydrogen will go to this water, and then this hydrogen ion will go to the other molecule. Now, we have something called the ion product of water. And the ion product of water, it's a constant at constant temperature, which is usually, we use it 25 Celsius. And it always changes only when the temperature changes. So basically it's a constant, but only when the temperature is constant. And we give it the Kw symbol, constant of water, or the ion product of water. Let's check. For example, if I have the water molecule H2O, and it will ionized in a reversible reaction that we studied previously, and it will give you H positive plus OH negative. Water is liquid because it's a pure substance. H positive is aqueous, it's a solution, as well as the OH negative is also a solution. All right. Now, if you remember, we have the Kc for the reaction, and Kc, it equals to the product of the products, each one to the power of its number of molecules. It means the number of moles in the balanced equation, divided by the concentration of the reactants. So here, if we apply it, we're going to have H positive, the concentration of H positive, multiplied by the concentration of OH negative, each one to the power of 1 and 1, because here we have 1 mole and 1 mole, divided by H2O. But the concentration of H2O is also constant because it's liquid, it's a pure substance. So this one is also constant. The concentration of the water here is constant. That means we can write this equation as Kc multiplied by H2O equals to H positive, concentration of the hydrogen ion, multiplied by the concentration of OH ion. And the Kc is a constant for the equilibrium. That means constant multiplied by constant, it equals to a new constant, and we name it the ion product of water, which is Kw. So what is Kw? Kw, this one, it equals to the concentration of H positive multiplied by the OH negative, or the concentration of OH negative. At 25 Kw, it has a fixed number, which equals to 1 times 10 to the power of negative 14. Now, at 25, Kw equals to 1 times 10 to the power of negative 14. That means at 25 also, if H positive equals to OH negative, that means the solution is a neutral. It's not acidic, it's not basic. But when the concentration of H positive is greater than the concentration of OH negative, it's going to be acidic. Of course, because we have more H positive, that means it's more acidic. And when we have H positive, the concentration of hydrogen ion is less than the concentration of hydroxide ion, then the solution should be basic. Let's have an example about this problem. The concentration of OH negative ions in a certain household ammonia cleaning solution is 0.0025 molar. Calculate the concentration of H positive ions. All right, now the concentration of OH negative is given, which equals to 0.0025 molar. The question is about the H positive concentration. It's unknown. If we apply this equation at 25 Celsius, we need to mention that at 25 Celsius, the Kw, it equals to 1 times 10 to the power of negative 14. And we know that the Kw, it equals to the concentration of H positive multiplied by the concentration of OH negative. Now, in this equation, we have Kw, we have OH. All we need to do is to find H positive concentration, which equals to Kw divided by the concentration of OH negative, which equals to 1 times 10 to the power of negative 14 divided by 0.0025. Using the calculator, you're going to find it is very easy. So it's going to be a very simple equation. All we need to remember is that Kw, the ion product of water, it equals to the concentration of hydrogen ions multiplied by the concentration of OH negative ions. And this amount at 25, it equals to 1 times 10 to the power of negative 14. Don't forget, when H positive equals to OH negative, that means the solution is neutral. And if H positive, this is the last thing, if I have, for example, H positive equals to OH negative, that means Kw equals to H positive square, or Kw equals to OH negative also square. That means when they equal each other, then the H positive equals to the square root of Kw, and as well as the OH negative it equals to the square root of Kw. Therefore, the H positive equals to square root of 1 times 10 to the power of negative 14, which equals to 1 times 10 to the power of negative 7 molar. As well as the OH negative also equals to 1 times 10 to the power of negative 7 molar. So when the solution is neutral, that means H positive equals to 1 times 10 to the power of negative 7, and we call this solution is neutral. Also, the OH negative will equals to the H positive, which equals to 1 times 10 to the power of negative 7, and the solution is also neutral. That means when when H positive, the concentration equals to 1 times 10 to the power of negative 7, that molar, that means the solution is neutral. And when H positive now is greater than 1 times 10 to the power of negative 7 molar, that means the solution should be acidic. And when the H positive is less than 1 times 10 to the power of negative 7 molar, that means the solution is basic. I hope you guys learned something new from this lesson. There is going to be a lot of parts for this lesson for acids and bases. So please, in the comments, if you have any question, please let me know. I will read all the comments. And please follow the following video, because it's going to be about how we calculate the pH and pOH. Have a nice day. Bye-bye.